This video is on accuracy and precision briefly, and there'll be a couple of percent error questions, which percent error is something you'll have to figure out several times throughout the year on different lab activities. But first thing, accuracy and precision. So accuracy is how close a measured value is to an accepted. So for example, if you go out to the lab and you measure the density of water, and you get 0.99 grams per milliliter. Well, the accepted is 1.00, so you're pretty close to the accepted value. That means you're accurate. So the way I remember that is accuracy starts with ACC, and you're close to the accepted value, which is ACC. Okay, so it's getting close to the actual value. Precision means if you have a series of measurements. So say you go out and you measure the density of water, and you get 0.71, 0.70, 0.71, and 0.72. Those are pretty precise measurements. In other words, you're getting the same answer over and over and over again. They're not very accurate, though, because they're not very close to the accepted value, which is 1. So precision means you're getting the same answer over and over and over again. Accuracy means you're getting close to the accepted value. If you're accurate and precise, obviously it would be the best. Here's another example. If you were shooting arrows at a target, okay, when you hit the center, that means you're accurate. Okay, so that is accurate. This one, all 3 arrows are in the same spot, so it's precise, but it's not accurate because you're not in the center. This one is precise and accurate. They're in the center, so that makes them accurate, and all 3 in the same spot. This one is not accurate or precise. None of them are in the middle, and they're not all in the same spot. So that's the difference between accuracy and precision. Something we often calculate is percent error. So if you measure this for your density of water and you're supposed to get 1, your percent error is pretty small. You weren't off by very much. Whereas if you measure this for the density of water, your percent error is fairly high. You're maybe almost 30% off from what you should have gotten. So your percent error is how far away are you from what you should have gotten. And you get that by taking your error, in other words, how much you're off, divided by what the accepted value was, and then changing it into a percent. Okay? So this kind of tells you how to do that. So let's look at an example here. Some students are doing an experiment. They find the experimental density, that means in an experiment, that's not the real one, density of alcohol to be 0.847 grams per milliliter. The accepted or real density is 0.793. So they were off a little bit, but not a huge amount off from what they should have gotten. So to get our percent error, our percent error equals, we need to subtract these two values, so 0.847 minus 0.793, and always subtract so that you have a positive number because you don't have a negative percent here. And make sure you do that before you do any division. And then we always divide by the accepted value. So this is not the accepted, that's the experimental. The accepted is 0.793, so divide by 0.793. Again, make sure you subtract and hit equals, and then divide by 0.793. Otherwise, your calculator will divide these two numbers and then subtract. So you get your percent from that. That's a pretty small percent. I should have this here for you. It's 0.847 minus 0.793, and then divided by 0.793. So you get 0.068. So remember, move the decimal 2 places over. That means we have a 6.8% error. So what that means is this number was 6.8% away from what they should have gotten. So that's not that far off. Another example here. Experimental time of an object from the roof of the building to hit the ground is 4.3 seconds. What it should have actually been measured at was 4.19 seconds. So again, get the percent error. So you do the same thing, the percent error, 4.3 minus 4.19. So subtract the two numbers to see how much they were off. And then always make sure you divide by the accepted. So 4.919 is what they should have gotten. Divide, turn into a percent. I'll remind you of that as we go through, but you do need to know how to do percent error problems